All right, this is section 7.4 over quadrilaterals, and a quadrilateral is a polygon that has 4 sides. So we've talked about polygons that have 3 sides. Those are called triangles, and so we have acute, obtuse, and right triangles. We have equilateral, scalene, isosceles triangles. Well, just like we can classify triangles, we can also classify quadrilaterals, these 4-sided shapes. So there's 3 main types of quadrilaterals. And the first type of quadrilateral is called a trapezoid. And so a trapezoid is a quadrilateral that has one set or one pair of parallel sides. You can say it says exactly one pair right there. And so that could be the top and the bottom. It could be the left and the right sides, but there's only one set of parallel sides. The other 2 sides don't have to be parallel. They do not have to be the same length. Even these line segments here don't have to be the same length. They just have to be parallel. If you have a quadrilateral that has 2 sets of parallel sides, that's called a parallelogram. And so not only will the sides be parallel, but they will be congruent as well. And so parallelogram, we've talked about plenty of parallelograms before. You can see the opposite sides here are parallel and congruent. So the red arrows indicate lines that are parallel with each other. So we have one red arrow, one red arrow. Here we have 2 red arrows showing you those 2 lines are parallel. And then the little red tick marks show you that these 2 side lengths are the same, and this side length and that side length are the same. And then we have kites. And kites are quadrilaterals with 2 pairs of congruent and then adjacent sides. So we know adjacent, that vocab word means next to. So these 2 sides are next to each other. They're congruent. And then these 2 sides are adjacent to each other and they're congruent. And it looks exactly like the same kite that you would fly in the sky. And that's really the only one you probably haven't seen before. That's why it's highlighted yellow, because that's probably the only one. If you have a quadrilateral that doesn't fit into one of these 3 categories, then we don't have a special name for it. We would just call it like this one here. There's no parallel sides, there's no congruent sides. This is just called a quadrilateral. But we can usually classify them into trapezoids, parallelograms, or kites. Now, there are different types of parallelograms. Sometimes we'll have a parallelogram that has 90-degree angles, and that's called a rectangle. You can see the opposite sides are parallel and congruent, and they have right angles. Sometimes we have a parallelogram that doesn't have right angles, but all the same sides, or all the sides are congruent there. That's called a rhombus. It's a parallelogram that has 4 congruent sides. And then sometimes we have a parallelogram that has features from both the rectangle and the rhombus, meaning it has right angles and all the sides are the same, and that's called a square. So a square has 4 right angles, all the sides are congruent, and the opposite sides are parallel. All right, so most of your homework tonight is just going to be classifying the different quadrilaterals. So in example A, we have a parallelogram. I know that because the sides are parallel. They're also all equal, and they have right angles, so this makes this a square. So yes, it is a parallelogram. It technically is also a rectangle and a rhombus, but we're going to give the most specific name. I want you to give the most specific name that you can. So yes, it's a quadrilateral. Yes, it's a parallelogram. Yes, it's a rectangle. Yes, it's a rhombus. But we wouldn't call this a rectangle because we know the most specific name is a square. In example B, we have the adjacent sides that are congruent. Those 2 sides are congruent, and these 2 sides here are congruent, and this is called a kite. And then example C, we have a parallelogram with the opposite sides, or actually all the sides are equal, and this is called a rhombus. So you'll want to refer back to this chart up here to make sure you are labeling them correctly. For example D, we have 1 set of parallel sides. That makes this a trapezoid. For example E, we have 2 sets of parallel sides, and they all have right angles. That makes this a rectangle. Obviously not a square, because the side lengths are different sizes. The opposite sides are the same, but not all 4 sides are the same. For example, F, we have a parallelogram that has, it looks like all the sides are equal, but they are not. You'll see this one has one little mark there. This one has two little marks. So it looks like it would be a rhombus, but it's not. It is just a parallelogram. Parallelogram. And then example G, we have one set of parallel sides again, and that makes this a trapezoid. Okay, so now that we've talked about classifying quadrilaterals, let's talk about the angle measures. We know that triangles have 180 total degrees, but that's not true with quadrilaterals. Quadrilaterals actually have 360, so double the degrees there. So if I add W plus X plus Y plus Z, the four angles in that quadrilateral, I'll get 360 degrees. So let's solve for X in these two quadrilaterals. And so what I'm going to do is I know that they have 360 degrees, so I'm going to start with 360, and then I'm just going to add up the angles I already have, the 115, the 70, and the 75. If I add those up, I'll know how many degrees I already have so far. So when I add those up, I get 260. Oops, I put plus. And I'm going to subtract 260 away from 360 to know what X has to be. And when I do that, I find out X is just 100 degrees. And then it wants me to classify the quadrilateral. Well, in this case, I don't have any sides that are parallel to each other. So I know it's not a trapezoid. I also know it's not a parallelogram. But a kite, which is the other option, means that the adjacent sides have to be equal, and that's not the case here. So I don't really have a special name for this one. I'm just going to call this one a quadrilateral. There isn't any special name for this one. We're just going to refer to it as a quadrilateral. Okay, and then example B, we have a 90-degree angle, an 81-degree angle, and a 124-degree angle. And that's going to be 295 when you add those together. So we're going to subtract that away from 360. And when we do that, we find out X is 65 degrees there. And then when we go to classify this one, again, we don't have any parallel sides. The opposite, there's no congruent sides either. So this is just going to be no special name for this one, just a quadrilateral. No special features in this one. All right, so in this one, we've got two 100-degree angles and an 80-degree angle. So we're going to do 360, take the total degrees, minus away the 280 degrees we already have. And when you do that, we will have 80 degrees left over. So this is 80 degrees. So when I go to classify this, you can see the angle measures are actually equal. The opposite angle measures are equal. And there's a reason for that. It's because we have parallel lines. So these two lines are parallel, and then these two lines on the right and left side are parallel. And so we have just a typical parallelogram here. Whoops, parallelogram. And then example D, we have two 90-degree angles and then a 118-degree angle. And that adds up to 298. So 360 minus 298 means that X is 62. Now, you'll notice that the top line and the bottom line are parallel, but we only have one set of parallel lines, which makes this a trapezoid then. So it only has one set of parallel lines. We call that a trapezoid. And then for example E, we've got two 122-degree angles and then a 58-degree angle. So that's going to make 302 degrees. So we're going to subtract that away from 360, and that means X is going to be 58 degrees, just like its opposite partner. So we have basically the same thing going on here that we had in example C, where the opposite angles are the same exact size. But not only do we have opposite angles being the same size, it looks like all the side lengths are also the same size. So if all four side lengths are the same size, we would call this a rhombus.